Hola, Mr. Sutton here, bringing you the IM385 Extra Practice number 2 solutions on probability of disjoint and overlapping events. For this problem, you and your friend are among several candidates running for class president. You estimate that there is a 45% chance you will win and a 25% chance your friend will win. And how you made that estimate is anybody's guess. So let's just roll with it here. So we want to know the probability that you or your friend win the election. So since we're talking about an or, we have to ask if there's any possibility of both of these things happening at the same time, and there is not. There's only one presidency here that you're both running for, so unless you're tied on votes, you can't both win at the same time. So this is a disjoint set of events, which means we just have to add the probabilities together. So probability of you or your friend, we've got the probability of you, which is 45%. Now we're going to add the probability that your friend wins, which is the other 25%, and then that's going to give us a grand total of, let's see here, 70% chance that one of the two of you wins this election. Best of luck to you. For this one, we're rolling a 6-sided die. We want the probability of rolling an odd number or a number less than 4. Since we're dealing with or, we have to wonder if there's some overlap between these two groups that we have to subtract. And there is. We do have odd numbers that are less than 4 at the same time. So since we have some overlapping going on, after we add these individual probabilities together, we're going to have to subtract the overlap. So now probability of odd or less than 4. Let's talk about probability of odd. There's a total of 6 numbers we could get rolling that dice. And so that's our total possibilities. Now, out of those 6, we only have 3 odd numbers, 1, 3, and 5. So that's 3 out of 6 chance of getting an odd number. Numbers that are less than 4, well, that's also 3 out of 6 because you have 1, 2, and 3. So that's added to the first 3 out of 6. But hold everything. Some of these odd numbers are also less than 4 numbers. We don't want to double count them. So that was specifically 1 and 3 are both odd and less than 4. So that's 2 out of the 6 numbers that are being double counted that we have to now subtract. So putting this all together, we have 3 plus 3 gives us 6, minus 2 gives us 4, 4 out of 6 chance, which we can now reduce to a 2/3 chance of getting an odd number or a less than 4 number. For this problem, we're randomly picking a number between 1 and 10, an integer, and we want to know the probability of choosing an odd number or an even number. So because a number can't be both odd and even at the same time, there's no overlap between these two groups. They are disjoint. So that means we just find the probability of both of these and add them together. So probability of odd or even. Well, what's the probability of getting an odd number here? Since we have an even number of numbers, we know that exactly half of them are odd and half of them are even. So for odd, we can write 1/2 for that probability, or you could do 5 out of 10, either way. And then for even, we also have 1/2, and we're adding that to the first half. So 1/2 plus 1/2 equals 1. So you have a 100% chance that the number you pick is either odd or even. For this problem, we have a bag of marbles, and we want the probability that we pick a yellow or a red marble. Since we're dealing with or, we have to ask if there's any overlap here. And a marble, at least the way this problem is set up, can't be both yellow and red. There's no multicolor marbles here. So these are disjoint possibilities. There's no overlap. So we're going to just find the individual probabilities and add them together. So these are going to have a total number of possibilities, a denominator of, let's see here, 2 plus 5 plus 7, that's 14. And now for the yellows specifically, they said there's 7 yellows, so 7 out of 14 chance of getting one of those. And for the reds, there's 2 of those, so that's a 2 out of 14 chance that we'll add to the 7 out of 14. And just adding those together, we get 9 out of 14. So those are the chances that your marble is yellow or red. For this one, given our bag of marbles here, we want to find the probability that our marble is red or not yellow. So is there any overlap between these, since we're dealing with an or statement? Are there some red marbles that are not yellow? Well, yeah, like all of them. There's definitely a lot of overlap here. There's also some not yellow marbles that are red, but not all the marbles that are not yellow are red. So there's some overlap, and we're going to piece it out as we go. So since there's some overlap, let's first take the individual probabilities here, add them together, and then we'll figure out whatever the overlapping group is and subtract that so we're not double counting it. So our denominator, since we have, let's see, 2 plus 5 is 7 plus 7 is 14, there's 14 marbles overall. So the probability of red, which is what we're going to start with here, is going to be something over 14. Now, they said there was 2 red marbles, so that's 2 over 14. Now, what about the probability of not yellow? Well, there are 7 yellow marbles, so that means the other 7 marbles are not yellow. So that's 7 out of 14 that we can add to the 2 out of 14. And now let's talk about the marbles that are both red and also not yellow. Well, all of the marbles that are red are not yellow because they're red. So that's an overlap of 2 out of 14. So that means we're going to have to subtract 2 out of 14. And that cancels with the first 2 out of 14, leaving us with just 7/14, which is just 1/2. Now, if you logic this out, if you're asking for the probability of marbles that are red or not yellow, that you're taking the reds and the blues basically. So that's going to be half the marbles. For this one, we have this bag of marbles, 2 reds, 5 blues, 7 yellows, and we want the probability of picking one of those 3 colors when we reach in and grab one of those marbles. Well, you could probably just look at this problem and say, well, I mean, that's all the marbles that are in the bag. There's no other type, so it's 100% probability that you get one of these. But let's do a little analysis and, prove it mathematically. So first off, since we have an OR going on, we want to know if this is overlapping or disjoint. Is there any overlap between these groups? And there isn't. These are all different colors, and we don't have any multicolored marbles. So since this is disjoint, we just add the individual probabilities without subtracting anything. So we've got 14 marbles overall, so that's going to be our denominator on all of these probabilities. For the blue marbles, they said there's 5 of those, so 5 out of 14 is the chance of drawing a blue. For the reds, we had 2, so we're adding 2 out of 14. And for the yellows, we had 7, so we're adding another 7 out of 14. So 5 plus 2 plus 7 gives us 14 over 14, which, as we anticipated logically, is just 1. For this problem, we're rolling a die, and we have 2 events, rolling an odd number and rolling a number less than 5. We want the probability of either of these things happening, A or B. Well, is there any overlap between these groups? If you're asking about OR, in general, we're adding the probabilities, but we have to ask if we have to subtract any overlap. Are there odd numbers that are also less than 5? And there are. Between the numbers 1 and 6, there's a few numbers that are odd and less than 5. Since we have some overlap, we'll have to subtract that later on. So now probability is going to be something over 6 because there's 6 numbers on that die. Probability of getting an odd number, there's 3 odd numbers, 1, 3, and 5. So that's 3 out of 6 for that. And then probability of event B, a number less than 5, well, that's the numbers 1 through 4. So there's a 4 out of 6 chance of getting those that we have to add in. But now we have to be careful because some of the odd numbers that we have in this first fraction are also numbers that are less than 5 from the second fraction. So which numbers are both odd and less than 5? Well, that would be 1 and 3. So that's a total of 2 numbers out of 6 that we must subtract. So adding this together, we have 3 plus 4 is 7, minus 2 is 5. So 5 out of 6 chance of getting one of these events. For this wordy problem, we have 162 students at an awards banquet, 48 getting awards for math, 78 for English, and 14 for both. We have a newspaper just randomly interviewing people. We want the probability they interview someone who won an award for English or mathematics. So since we're talking about an OR, we have 2 different probabilities that we need to add together, but we also need to consider if there are any people that fall into both groups. Were there any students that got awards for both English and math so that we don't want to double count them? And if we look back up here, it said there are 14 students who won awards for both. So yeah, there's some overlapping. So we're going to have to subtract that after we add these together. So now let's talk about our overall number of possibilities for students. There was 162 of them. So that's going to be our denominator in all these probabilities that we're adding together. And if we're just talking about the English award winners, they said 78 won awards for English. So there's a 78 out of 162 chance that a student randomly picked won an English award. For the math, it was 48 out of 162. But now hold on a sec. Some of this 78 and 48 were students who won both awards because they were counting them separately. That's 14 students out of 162 that we want to subtract now so that we're not double counting them because they're included in both of these two original groups. So now putting all that together, 78 plus 48, that's going to be, let me see here, 70 plus 40 is 110, 8 plus 8 is 16, so that's 126 minus 14, so 112 over 162. And then if we want to reduce that, that can reduce by 2's to give us 56 over 81, and it doesn't look like that can be reduced anymore. For this one, we have a card being chosen from a standard deck of 52, and that's going to be for all the problems in this set of problems. We want the probability your card is a queen or an 8. Okay, so we have an OR going on, so we have two different groups that we have to add together for probabilities. Is there any overlap between these two groups? Well, queens and 8s are different types of cards. You can't be a queen and an 8 at the same time. So these are disjoint, so we're just going to add the probabilities without having to subtract any overlap. So probability of a queen or an 8, let's deal with the queens first. Out of a deck of 52 cards, that's the total possibilities, 4 are queens, 1 for each of the different suits. So that's 4 out of 52. And for the 8s, there's also 4 8s in a deck of 52, so that's plus 4 over 52. And there's no overlap, so we just add these without doing anything else, giving us 8 over 52, which we can reduce to 2 over 13. On this problem, we want the probability from a deck of cards that we get a queen or a diamond. So with these groups, there are some queens that are diamonds. Well, there's one queen of diamonds. So there's some overlap between these groups, which means after we add the individual probabilities, we have to subtract that overlap. So probability of a queen or a diamond, for the queens, there's 52 cards total, and 4 are queens. So we have a 4 out of 52 chance for those. For the diamonds, there's 13 of each suit in a deck of cards, so we have to add 13 over 52. And now, how many fall into both of these categories? Well, again, there's only one diamond that's a queen. It's the queen of diamonds. So that's 1 out of 52 that we have to now subtract. So we have 4 plus 13 is 17, minus 1 is 16 over 52. And reducing this by 4s, we end up with 4/13. For this problem, we want the probability that our card that we draw from a deck of 52 is a black card or a face card. Now, it's possible to be both of these at the same time. For example, the Queen of Spades is both. So we have some overlap we're going to have to take into account. So now, probability of either of these, let's find the probabilities of either of them separately and then add them, and then we'll deal with the overlap. So for black cards, overall we have 52 cards. Half of them are black cards, so that's 26 out of 52 for the black cards. For face cards, we know that there's 3 types, jacks, queens, and kings, and each of those types is for all 4 suits. So 3 times 4 gives us 12 out of 52 cards that are face cards of whatever suit. Now, after we add these together, we have to be careful because some of these black cards are also face cards. We don't want to double count them. So how many black cards are also face cards? We have the jack, the queen, and the king of spades and of clubs. So there's 6 of them that are both. So we'll have to subtract 6 out of 52. Putting it all together now, we have 26 plus 12 is 38, minus 6 is 32. So 32 over 52, which we can reduce to give us, if we reduce by 4s here, that's going to be 8 over 13. For this one, given a deck of 52, we want the probability that a randomly drawn card is a red 4 or a diamond face card. So since we're dealing with OR, we have to add these probabilities together. Is there any overlap, though, between these groups? Can you be a red 4 or a diamond face card? You can't, because the face cards and the 4s are distinct cards. Some of the red cards are diamonds, and all of the diamonds are reds, but the 4s and the face cards, those are totally disjoint. So since these are disjoint sets, we just add them and don't worry about any overlap. All right, so we have red 4s or diamond face cards. Let's deal with the red 4s first. So overall, there's 52 cards to choose from. And for red 4s, we have the 4 of hearts and the 4 of diamonds, and that is it. So that's 2 out of 52 that are red 4s. For diamond face cards, we have the jack, the queen, and the king of diamonds, and those are the only diamond face cards. So that's 3 out of 52 that we have to add in there. And again, there's no overlap between these groups, so we just add them and call it a day. And that is going to be 5 out of 52.